Thank you so much for joining us today. My name is Jill Weidman, and I'm the Executive Vice President of the Tutor Beta Institute. And I'm here today with Michael Thiessmeier. He is the Executive Director of the National Artificial Intelligence and Cybersecurity ISAO. On behalf of the Tutor Beta Institute and the NAIC ISAO, we would like to welcome you to our recap session. The Tutor Beta Institute was created to promote collaboration across public and private sectors with a focus on business, culture, and diversity. We're looking to reshape and develop collaboration and partnering practices with a view to improving and securing business and economies. If you're not currently a member of the Tutor Beta Institute or the NAIC ISAO, we invite you to our website and learn more about us and see how you can join. Michael, why don't you give us a brief overview of the NAIC ISAO and the SCSP to help the audience understand the setting?
Of course. So first of all, thank you for having me. Jill, I always love talking to you. I mean, we've been working with each other now for years, so I think we can kind of do this as like a relaxed conversation style with each other. All right, cool. So the ISAO, right? ISAOs are information sharing analysis organizations. Originally, the focus of an ISAO is very much on threat intelligence. What we're talking here about is cyber threat intelligence at the intersection, in our case, of AI and cybersecurity. How does AI affect cybersecurity, and how does cybersecurity affect AI? But as we kind of evolved throughout the past couple of years, we figured out that threat intel just isn't enough. Because it's not just national security, it's societal security. And so many things kind of fit into that, right? From capacity building, cyber diplomacy, regulatory policy, national policy advisory, even go-to-market strategy. So the ISAO has various programs, some very mature, some just starting, basically, where people are just trying to put their foot in the ground. And we are doing this now on 3 continents: Latin America, North America, and Europe. So that's us in a nutshell. The SCSP is a think tank that came out of the National Security Commission on AI. And we very early on, through a friend of mine, established a relationship with them, where we interfaced briefly with the NSAIC, I think is what it was called. And then afterwards, that relationship just continued to live on, where we occasionally interact with each other, exchange information, or go to events and attend events together. It all depends on the exact format. So I would say that summarizes kind of both organizations.
Perfect. And how about a quick overview of the event itself? I know it's a really big deal to be even invited to this event.
Okay, so the SCSP is hosting a series of events focused on AI. I think they call this the AI Plus series, if I correctly remember.
Yeah.
So they will have now one on robotics in a few days, and this one was on energy. And their goal is to kind of get together the top leaders of industry, academia, and government, the thought leaders in each of these aspects, a limited number of those. I think they originally went with 400 for the AI and Energy Summit and then scaled it down to maybe like 300 people. Bring them together to discuss and kind of work out some of those solutions that we need to define the path forward. In this case, as it relates to energy and AI, also how they how they affect each other. So that was the event.
Okay. So energy policy is not the first thing that I think about when I think about the ISO. So why did you think it was important to attend this event?
Yeah, so I'm exactly in the same boat as you are when it comes to that question. Definitely wasn't the first thing I was thinking about either. Specifically when I saw the invite in my email inbox, I was like, that's an interesting piece. But then go back to the kind of our mission and our scope that I defined earlier, right? If you want to ensure the safe use of AI in society, if you worry about societal resiliency into societal security, you need to kind of have an understanding of all the different factors or primary influence variables, the constraints that affect that subject. AI is the subject, right?
Yeah.
So energy is one of them. And then finally, of course, energy is critical infrastructure. So now we're going back all the way to the beginning of the mission statement of an ISAO, which is how do we protect the infrastructure that our very society relies on? So that kind of made sense to me. And then beyond the like, oh, I'm getting invited to an event where there will be all of these very important people. Beyond that, it was that made me decide to want to attend that.
Awesome. And what was the overall atmosphere or vibe of the event as it relates to the challenges that we're facing?
Ooh. Well, so the event was in Washington, D.C., right? And it was in a very, very nice hotel. I wished I could remember the name of the hotel right now, but it was like close, directly very close to the White House and very prestigious. And you're going to this event then, and everybody realizes that everybody that's here is here for a reason, right? Beyond the like top A-listers that are going to be speaking, like Bill Gates. I mean, we had Eric Schmidt, former CEO of Google. Like we had the Secretary for Energy. We had all of these really, really very important people that were speaking as well. So you realize the setting already goes in and sets the stage.
Yeah.
Then you have Uriel Bayraktar, the executive director or CEO of the SCSP, speak and basically pose this giant challenge to you, which is that, well, what we're going to do here, ultimately, the thoughts, the pieces that come out of this summit will affect what AI means worldwide, but even more importantly, will affect all future generations. And that gives you already a little bit of puts you a little bit, in your place, if I may say this, and puts you in a little bit of a somber mood, because we all kind of individually, based on our expert backgrounds, have an idea of the giant challenges involved, whether you're from the energy capacity, energy storage, energy generation areas, or from cybersecurity, national security, or regulatory perspective. But that's not even all, because on top of that, you start realizing that some of our strategic opponents, like China, are in certain areas in a way better position than we are, specifically when it relates to building infrastructure. Now, this is a very precise building infrastructure. They don't have any constraints there. They can do this in any way they want. And currently, they're outperforming the US by a factor of 2 when it comes to generating capacity. That's not something that we as Americans should accept. Now, luckily, it's not just about construction when it comes to AI, right? Building and constructing things is very important, but it requires innovation, strategic foresight, and being able to have frank and honest dialogue across all sectors of society. And that's something that authoritarian nations aren't good at. And that's something that I think this summit was primarily designed to achieve.
Awesome. When we look at building and we start talking about innovation and, where AI is and the large language models, how do you think that that's going to impact our energy demands?
Well, I think you're seeing a lot of different numbers being thrown around. I will stick with the numbers that were presented and talked about in the summit. So, first off, by 2028, we expect that the energy demand of all data centers is going to surpass the energy demand of the combined populations of California and New York.
Wow.
Yes. Now, for our international audience, you have to understand how big those states are and the economies. Talk about California, you're talking about an economy that's maybe this month, maybe in the first quarter of next year, is going to surpass the German economy in size. New York is a little bit smaller, but isn't far beyond that either. So when we're talking about states or cities or whatever, you have to realize we might as well be talking about the biggest European countries here. And taking 2 of them, smashing them together, and the energy demand is larger than that. That's not all. Also, by 2040, just in the US, we probably would have to build somewhere close to 80 million square kilometers of energy grid. That is more than we have in the entire world right now.
Wow.
But let's make it worse, because we already said this now. It's not only 80 million square kilometers. It also needs to be bidirectional and need to have rapid failover and switching capacity, which the current energy grid doesn't have. So we are on top of that. Not only do we need to update the current energy grid, But we also need to build new energy grid, and that using new technologies that largely currently might not even be in place. And we just discussed grid right now. Let's go to the next point. Energy generation itself. The only technology capable of keeping up with this demand that we currently have, not in 5 years, not in 10 years, not in 50 years, is nuclear. But for very good reasons, building current nuclear reactors and then having them go through the approval process, the regulatory approval process, takes time.
Yeah.
It takes for each of them, I forgot what the number was, whether it was like 20 years or 25 years each.
It's
For
massive.
each of them, it takes way more time than we actually have, because you saw that 2040 number, 80 million square kilometers. You saw the 2028 number, more AI demand than two of our largest economies that we internally have in the US. We don't have that time. So then the question is, what's next? Well, Sam Altman is talking about micro generators, basically small micro reactors that can be placed into data centers and ran and administered locally. Other principles are very much aligned, or other ideas are very much aligned with this. They're called SMRs, small modular reactors. That's basically, I think, almost the same thing. It's just talking about different sizes and different potential use cases here. But all of this requires additional regulations, because again, we're talking about nuclear reactors. Whether they need as much or less is a different question. That's not my specialty area. But even those frameworks don't exist right now. And of course, lots of that technology is like cutting edge, just being put in place. So if we don't have this, then what else? Well, there were some improvements in fusion technology. A lot of hope seems to rest on fusion technology, but the question is this kind of like waiting for external intervention to save us from an unsolvable problem? By now, our head should be spinning based on everything that I've mentioned. But there's more and more areas. How about energy storage? We've just generated energy. We're able to move it around, but we still got to be able to store it. Well, lithium ion is so inefficient. That's not going to cut it. So we need to find new, different type of batteries as well. And they're being developed. There's moves being done there. But if I correctly remember, even the delta between where the actual storage efficiency is supposed to be and where we are is still rather big as well. But again, that's not my specialty. Just want to point this out. So in summary, there is a lot of innovation that needs to be done. There's a lot of infrastructure investment, development, building that needs to be done. And of course, we need to figure out what are the regulatory frameworks that can support all of this.
Yeah. And I mean, I would imagine that AI will be a part of helping us reach this. How do you think that what its role will be in helping us to reach this?
Well, of course, AI is able to help almost at all stages of this process in some way, some form or another, right? Whether we talk about research and development, whether we talk about operations, in all these stages, it can help us. So first off, when we're talking about research, right? Like experimentation, like dealing with large data sets, everybody understands that AI is able to help us there come to better conclusions, run better simulations. And that might help with all sorts of technologies that we need to develop, whether it has to do with very basic research as it relates to particles to make fusion work, or whether it has to do with figuring out the best materials to accomplish certain tasks. No question there. All right, next step. Next step is prediction of energy demand. Well, that's a given, right? If I have a giant data set, assuming I can do real-time monitoring, then I can figure out what's the best way of predicting future energy demands. At the same time, I can figure out the best and most efficient routing and storage as well, and use AI to accomplish that task. But still, this is not going to cut it. There's other aspects here, and there are bigger challenges, because keep in mind, when we talk about a grid, we talk about resiliency as well. And resiliency comes down to many things. And then there's one piece that affects both the ability to predict energy demand as well as deal with resiliency events, switch over capability. That has to do with, well, weather prediction, weather forecasting. The better our models are, we just had like how many hurricanes hit Florida the past month? It was 2 in rapid succession, right? So if we understand weather trends better, not only can we figure out, of course, like energy demands based on simple, like, okay, it's going to be a heat wave, and in a heat wave, this is how energy demand is going to scale with that, but we can also figure out what the likely impact of a certain weather event is in general for the grid. What are the risk areas? Like better understanding of this, like which areas not to build certain things in and which areas to build things in, which that is already fairly, I think we're fairly good at that point. There's like a lot of data that FEMA has on flood zones and potential damage impacts based on events, but we can always get better. So I think that there, the modeling AI has a lot to give as it relates to how weather forecasting affects the energy grid and affects the actual utilization of energy. Then finally, I talked about switching, which means like actually responding to events and operating in the nitty-gritty detail the energy grid. I think there's a lot to gain there as well. Of course, the immediate question is how much control are we willing to give away, right? Because this is OT, operational technology. Operational technology is, well, in a lot of cases behind massively. That is because you're using like incredibly old interfaces and whatnot to actually operate those networks. There's an advantage of that as well, which is that a lot of these devices are running on I'm not even going to call it, I'm going to call it embedded systems, and using interfaces that are horrible to work with. So for a hacker to compromise those systems, a lot of the nice utility functions and all the creature comforts you're used to when working with a Windows operating system, they don't exist. A lot of, and you might be working across a interface that you've never worked with, or that is like operating at snail's pace. So that also works in your favor, or in our favor from a protection perspective. But when we're talking about using AI, this can also, again, work against us because the OT might not be able to easily, with us developing other like control and interfaces in between, with us modernizing things, might not be able to easily control, interact with any of those OT technologies. And then the last, cyber threat intel. The last piece of protecting the grid. Obviously, AI has already, and yeah, vendors are putting right now AI on every single cybersecurity product. Let's be honest. We've been using machine learning, pattern recognition, user behavior analysis on cybersecurity tools for the past at least, I don't know, 10 years?
Yeah.
Maybe 16, maybe 12. So their AI, of course, is going to have a massive impact as well.
Absolutely. Let's talk about the international context and implications with this.
Okay. Let's start with something that's often said. The US innovates, the EU regulates, and China replicates. Generally speaking, I do agree with this statement. And I think Eric Schmidt during the summit brought up some very interesting points that paint an even grimmer future for Europe. Like if you're looking at all these challenges that affect us, that's one thing, but if we're looking at the international context, if we're looking at the challenges that the EU is facing, I think there's a lot more. So I always sometimes say like, okay, so like the America is the heart of the Western world, and the EU is the soul, right? Like it's kind of like the EU really tries to protect consumers, to create regulations that are favorable of the environment and favorable of individual rights, and privacy is a big cornerstone of individual rights for them. That is very commendable. But let's keep in mind what I said earlier. The only technology that we currently possess that can keep up with energy demand is nuclear. Which direction have many EU countries taken as it relates to nuclear? They shut down their reactors. So here then comes the big issue, and this is what Eric Schmidt said. I'm going to paraphrase his what he said. He says that it will very soon become infeasible to train AI models in the EU. That's a massive issue. The reason he mentions that is the cost involved in training AI models, given current regulatory impacts, given current energy policy, and the constraints on energy generation that the EU is facing. So that by itself is already really bad. If you're saying like it's too expensive, then the immediate question that follows is okay, so where could you train the models? Well, the next best place is the Middle East, specifically KSA and UAE. Well, okay, so that will bring up a variety of problems. The first problem is data sovereignty. The EU was talking a lot about data sovereignty. All data should reside within the EU, blah, 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 blah. We are talking about this right now as well as it relates to AI models, which is we say that AI models, our data centers that we use to train AI and for national security purposes, should be in the US.
Right.
Now for me, Silicon Valley mindset, as somebody who has worked in companies that had 1,200% growth rate year over year, the immediate like alarm bell rings up, and I'm like, one of the biggest reasons we were able to grow as quickly was because we had unrestricted access to the global market, and because we're able to have simple infrastructure. And what that means, if we have data sovereignty, or if I have to have localized data centers, like one for the US, one for the EU, you just doubled my entire infrastructure cost, you doubled my complexity, and you doubled my need of staff or whatever. And maybe not doubled, because obviously I can do something, but basically right. You really, really hampered my ability to innovate and operate and grow as a business. So this immediately, even in the US, is going to, out of my perspective, cause an issue for innovation. But let's go back to the EU. Data sovereignty is a core aspect of ensuring privacy. GDPR talks about this.
Right.
So now you're saying you're going to train AI models based on EU data in a state, in a country that doesn't even right now have a privacy agreement really with you. That is definitely not equivalent when it comes to privacy protections to the EU. And on top of that, and this is why I brought up this little soul thing, that when it comes to ethical alignment, human rights, and those things that Europe holds very, very dear, is absolutely not aligned.
Yeah.
So you're compromising the very, not only are you creating a situation where you basically now have to pick, am I going to fall drastically behind in AI research and innovation, or am I going to compromise the very values that I put first as the EU by having to go to the next closest destination and probably even like scrap like a lot of my privacy protections in the process of doing so? Compromise your soul or compromise your very being kind of situation here. I don't know what the answer to this is. I think it's very scary, and as a former European, it kind of makes my heart hurt and bleed a little bit to see them having to go through this. Because generally speaking, I'm pro privacy rights. You know, I think people should be in control of their data, but you can't lose the AI race. That's impossible, right? Let's keep in mind what AI will do for society. It's like saying I'm not going to go and employ, like falling behind. It's like saying I'm going to fall behind with electricity or using like combustion engines or something like that. Like you're going to put your society at such a massive disadvantage versus other societies. It's not a choice that exists. So I'm going to look forward to see kind of how they will navigate this. I don't really know what the solutions there are, except for giving up on some of the things that they hold dear.
Wow. So, I mean, this is really a grim picture that we're painting here. What a way to start the day. You know, what are some possibilities, Michael?
I'm going to go back to, again, Eric Schmidt. Yes, the challenges are huge. This is not the first time we faced huge challenges. We faced them at multiple phases throughout humanity and in the United States history as well. The fact is that the US is in an incredibly strong position, especially compared to the rest of the world. Our innovation ecosystem, our financial ecosystem, our technology sector is the envy of the world. That's just what it is. And when we put all these different chips and pieces together, we are able to achieve things that's, quite frankly speaking, others cannot. Let me give you a simple example to underscore this. 10 years ago, the United States was the largest importer of energy in the world. Decisions were made, projects were put in place, people started acting. Now, 10 years later, we're the biggest exporter in the world in just a decade. So I would say that while this is an incredibly grim picture, initially, if you look at the challenge, we should not forget many of the historic situations we found ourselves in that we were able to overcome, and we should trust in our core strength.
Awesome. So, what was the final outcome of the summit?
Well, I mean, I think maybe we can post it online after this conversation again a little bit. Obviously, the summit resulted in a memo that the SCSP submitted to the US president with a list of recommendations that they think we should take. And I agree wholeheartedly with all of these recommendations, by the way. I just want to say that in order to ensure we can meet this challenge. If I were to summarize this, the first thing is, of course, they set the stage in the memo, right? They explained exactly the challenge that I just explained on this call. The next thing is they brought up the principle of a great new deal, right? We had to go and transform the interstate highway system in the United States. By doing so, we invigorated the economy and created opportunity left and right. In a similar way, if we want to meet this challenge and with that take advantage of the opportunities that come with leveraging AI and being able to maintain world leadership in AI, it will require a, you could call it grid new deal, as I think the word they're using. It would require that in order to modernize our electric infrastructure and to invest into it. And some critics might say, oh, that is one more time an attempt at spending our way out of a crisis. But I think in this case, you have so many people from so many different walks of life, from both parties that align with that say, like, look, like, I mean, what's the option here? We are not investing in our energy grid. We're just going to say, nope, we're not going to keep up with AI's energy demands. That's not an option. So the only thing then is all in and going in and creating this new grid deal. The other aspect I think has to do with, in terms of recommendations, has to do with the regulatory environment. Here, we're definitely different than Europe's approach. And, I'm always trying to present a balanced view of things. Let's be honest. Yes, we are in a situation where we will need to be able to innovate rather quickly. We need to be able to identify the right technologies quickly, and if they are helping us solve any of these challenges, connect them with funding, build them up, mature them, and get them operational in incredibly small timeframes. That's only possible if A, we have a regulatory environment that supports that, and B, we have the investment environment that supports that. Now, for me, in my mind, this creates a couple of challenges. Number one is when we're talking about nuclear reactors, fast tracking them, some people might have mixed feelings about this, probably for very, very good reasons. On the other hand, this also directly relates to, we're not talking about technology innovation that might happen actually in really, really small startups, right? That don't require yet for the initial spark massive amount of money. And this means that this type of, I'm going to call it dual use technology, might develop anywhere in the world. So we also should have a ability to go in and detect, scout for those valuable technologies, no matter where they pop up in the world, and then fast track them, which there is a program in place already for that. Fast track them and figure out how to leverage them for us. I think that's a very, very important part as well. But again, it goes back to how much regulation is good and how much regulation is not good.
Yeah.
Because there's now national security concern here. You're saying, oh, we need to look globally at tech in order to make sure we can transfer what's valuable into the country. But the core point is, again, into the country, transfer of technology into the US. And there has to be a conversation here about how does national security work in this new world? If we're talking about technology that's being built everywhere, that is being built by a select few, Werner von Braun was German, and we took him into the US and made him work for us. How do we accomplish something similar when we see like one of these like mavens, one of these like geniuses pop up to get them to be here? Because I, personally speaking, I think that national security and with that, when we talk about clearance processes, I think we have better data points available, specifically if we're talking about AI nowadays, than relying on what is printed in somebody's passport. I mean, if we're looking at the latest like leaks, if we're looking at leaks and all this kind of stuff, it's not like just because somebody is a US citizen, they suddenly are much more loyal than if they're not. That's related to other factors. So we have to make this workable as well. And I think this is currently not really covered in the regulatory aspects that are being discussed in the memo itself. The last part, talking about public and private partnership. I mean, that's our bread and butter, right? I was really, really happy to see them actually mention this and to talk about this. They're bringing up here the FAST initiative from the Department of Energy, which is exactly what I was talking about. Identify technologies, fast track them to scale them up. I think that's very important. But this also, of course, how would I say, creates the opportunity for organizations like ours to interact with all of these stakeholders and make sure we connect the right dots. We have the right conversations across a multitude of industries, because at the end of the day, energy is only one facet of the greater challenge of researching, innovating, developing, implementing, and safely using AI in a society. So I think there's some opportunities there that for us specifically to make this usable.
Awesome. Michael, thank you so much. We've run a few minutes over. I appreciate your time so much today. This has been an amazing conversation, and I'm so glad that you took the opportunity to go to this event because, like you said, it really does tie into what we're trying to do at the Tutor Breda Institute and the NAIC ISAO. And I look forward to seeing how we can take this and move it to the next level. Thank you so much for joining us today. Again, if you haven't heard about us or you want to get involved, please check out our website and see how you can get connected with us.
Thank you so much. It was a pleasure.